So, in the last class we have started the project management, where we have seen that whenever we are having a project, the project is being divided into several subcomponents, which we are telling as activities or events, and we want to see the flow of the activities using some diagram, what we called as the network model. And so, for the project we are drawing the network model, and from the network model we will see the flow. Now, to find out the duration of the project, the cost of the project, how the duration of a project can be reduced, for that, as I discussed in the last class, there are two mechanisms. One is critical path analysis, another one is the part. So, today at first we will start with the CPM, that is critical path analysis, how to find out the solution of the critical path analysis. If you see here, as soon as the network is drawn from for the given project, the time analysis is required for planning of various activities of the project. So, the main aim of time analysis is to prepare a planning of schedule for the project. So, what critical path analysis done? It is a special method for time analysis to determine basically two things, as I was telling, total duration of the project completion, and the number 2 is categorize the activities of the project into two parts, one is critical, another one is non-critical. Or in other sense, we want to say that we want to find out the duration, total duration of the project, and whenever you are having the activities, from the activities of the nodes, we want to find what are the critical activities, what are the non-critical activities. Now, critical activities means which we have to closely watch. For non-critical activities, we do not want to watch closely. First, let us see the definition of these two. Critical activity, an activity in network diagram whose delay in the beginning will further delay the project completion time. You see this one, whose delay, critical activity is the activity whose delay in the beginning will further delay the completion of the project or project completion time. Or in other sense, if you see, if I have drawn a network something like this, it is going like this way, and so it is going to end. So, this is your starting node, this is your ending node. Now, this activity, if you consider, this activity I will tell as critical activity. If I start it late, then the project completion time also will be late. Suppose project completion time is 10 days, and if I start this 1 day later, if I start this activity 1 day later, then this will affect the project completion time, say it will become 11 days. So, basically if I delay the process of starting of one activity, which causes the completion of the project also in the delay further, that activity we are calling as the critical activity. So, what is non-critical activity? The non-critical activity is an activity which allows some scheduled slack, so that the start time of the activity may be delayed or advanced within some range without affecting the completion time of the entire project. You see this one, here you can allow some scheduling slack, so that the starting time of the activity may be delayed or advanced. That is the if you want, you can delay it little bit, if you want, you can advance it little bit, but that will not affect the project completion time. If you see in the figure, suppose I have drawn something like this, along with this is again the end node. For this particular node, this will be a non-critical activity. Whenever we will, if I start it at the beginning 1 day earlier, if I start it 1 day later, this will not affect the project completion time. Or in other sense, if this activity starts beforehand or if it starts after 1 day, the project completion time remains 10 days only, then the activity is known as non-critical activity. So, I hope it is clear. Critical activity means the activity, if you delay the beginning of that activity, this will affect the completion of the project, whereas for non-critical activity, whether you start the activity beforehand or afterhand within some range, of course, it will not affect the project completion time, then that one we call it as the non-critical activity. So, basically we have to watch closely that we are starting the critical activities at the very pinpointed time, otherwise you cannot complete the project in the scheduled duration. So, you have to note this one, that at first I have to find out by some mechanism which activities are the, from these which activities are the critical activities and which are non-critical activities. So, that afterwards if we wish we can change the values of the critical activities and we can check what is the effect on the project completion time. Now, how to find out these things? For this, for calculation of the critical path, we will use some notation. Just see this one. EI, capital EI is the earliest occurrence time of event I. LJ is the latest occurrence time of event J. LJ is the latest occurrence time of event J, that is earliest when it will occur or latest when it will occur, that we are denoting by EI and LJ. I comma j, activity, one activity is denoted by this with head as j and tail as I. If you see here I to j, so this is the head basically, this node is the head, this node is the tail. So, I comma j means head is this and tail is this one. So, I comma j denotes like this. The next one is the T I j, duration of the activity I j. So, as I was telling, duration of the activity I j means T I j is this one, this T I j will be this thing. The duration of the activity or the completion of this activity takes how much time or what is the cost, whatever way you want to take. So, this we call T I j, duration of the activity I comma j. Next one is E S I j, earliest starting time of activity I j, that is one activity I j at the earliest when I can start, that is E S I j. Similarly, L S I j is the latest starting time of the activity I j, latest we can when you can start, that is one activity can start at the beginning at most when and at most on the other part with. What is the range? This range we are calling as E S I j, earliest starting activity I j and the latest starting time of activity I j. Similarly, for the finishing also we have two notations, E F I j, earliest finishing time of activity I j, and L F I j, that is latest finishing time of activity I j. So, these are the notations we will use, you will see afterwards. Now, let us see the whenever we want to calculate this, we use basically the two methods, one we call as the forward pass method and one as the backward pass method. Let us see first the forward pass method, what we do. In the forward pass method, we start with the initial node, just like in the diagram. In this diagram, this we call as the initial node. This one is your initial node. This is the initial node and this node we call it as the end node, that is this is the end of the diagram. So, at first we have to start with the initial node and then with starting time of the project as 0, whenever you are starting time, obviously that starting time we should assume as 0. We move along the nodes with increasing order of node number. Increasing order of node number means the serial number 1, 2, 3 like this way, and we have to end at the final node of the network. At each node we have to calculate the earliest start time and earliest finishing time, that is the E I and L j. These two we have to calculate. At each node we will calculate the earliest start time and the earliest finishing time. Now, what would be the algorithm for this one? If you see the algorithm for forward pass, so step 1 initialize I equals 1 and E 1 equals 0. So, in the figure if you see, you will take say this one as E 1, this is E 1 equals 0. So, this is your starting one. If this node is 1, say this node is 2, something like this, we will see in the figures. So, at first I will make E 1, this is equals to 0. Next step is we have to calculate the earliest start time for each activity that begins at node I and earliest start time for each activity that begins at node I, E S I j, which is equals E I, that is for all I j with starting node at I. Then step 3, compute the earliest finishing time of each activity at node I. This we are denoted as EFij. The value will be ESij plus Tij. ESij already you have seen the initial value, that is EI. So, it will be EI plus Tj, where Tij, where Tij is the duration of Ij. Whenever we are going through the problem, you will see how we are calculating. The mathematical part let us finish first. Step 4 is you have to proceed to the next node, say node j, and we have to complete the earliest occurrence time for node j. First, the earliest occurrence time, if you see the formula we have given, E j equals maximum over I EF I j. This is equals maximum over I EI plus T I j, EI plus T I j. So, that means what? Why we are telling the maximum? Maximum means, suppose you are having something like this, you are having this, from these two you are getting another one, that is this one, the flow is something like this way. So, whenever you are trying to compute for this one EI, that is earliest completion time, earliest occurrence time for this one, it depends on both these. I have to calculate what was the value of here. So, this is E2, this is E3 and this is say E4. So, what I will do, this activity Tij, that the duration is, say it is 3, it is 2, here E2 is 10 and E3 is 8 suppose. So, what will be E4? Whenever you are calculating E4, you calculate E2 plus Tij, that is you are getting 13 maximum of I, 13 here you are getting 13 comma, here it is for this one, for this link it is 8 plus 2, that is 10. Maximum of these two whatever you get, that will be the value of this, that is E4 will become not 10, but 13. So, like this way we are telling that the maximum value will be from these two node, it may be whenever the node is joining from more than one cases, one activities, then we will take the maximum value. So, we are calculating in step 4 the earliest occurrence time. Step 5 is the earliest finishing time. The earliest finishing time will be similarly your, if j equals n, if you see you are going on, whenever you are going to the j equals n, the last node, that is this, whenever j equals n, in that case your formula will be E n equals maximum over E f I j, earlier finishing time I j, that is you just see the PPT, in the PPT it is E n equals maximum over E f I j, and which is equals E f I j, you can write it as E n minus 1, that is the earlier node plus T I j. Now, n minus 1 node means this, it may be this, it may be this one also. So, therefore, for the last node it is equals to maximum of E n minus 1 plus T I j. So, this is your forward pass calculation. So, forward pass calculation basically what is happening, if you see this is your starting node, this is your ending node, if it is this, you are calculating E1 first, then E2, then E3, then E4, like this way forwardly one by one, by sequence wise you are calculating the earliest completion time, occurrence time and earliest finishing time. This is the basic idea of the forward pass. Now, let us see the other one, that is I told you, the backward pass calculation. In the backward pass calculation, basically it is just the opposite of the forward pass calculation. That is, we begin from the terminal node of the network, proceed through the network, visiting the nodes in the decreasing order of the node number and end at the initial node. At each node, we calculate the least finishing time for each activity. That is, for this one, basically I will start the least time from the end node. From L4, I will start, what will be the value of L4? Value of L4 will be whatever we got for E4, that is the earliest completion time. So, L4 will be initialized with this, then you will calculate L3, we will calculate L2, we will calculate L1. Like this way you are proceeding. So, basically from backward or from the end node you are starting, end activity you are starting and you are proceeding, ultimately you are coming to the beginning one. So, this is the basic process of the backward pass calculation. Let us see the steps. In step 1, as I told, initialize ln equals en for j equals n. Already through the backward pass calculations you know what is en. So, ln equals en. Step 2, set the finishing time for the activity I j at the end node of j as lfj equals lj. Step 3, calculate the least starting time as ls I j equals lf I j minus t I j. Here you note one thing, for forward pass we were calculating lf I j plus t I j. Here we have to make the minus because we are going to the backward side. And similarly, in step 4, you proceed backward to the node in the sequence decreasing by j by 1, and the formula will be here Li equals minimum over j ls I j, and ls I j is nothing but basically Lj minus Tij. So, minimum over j Lj minus Tij. For forward pass we were doing the maximum over I Lj Li plus Tij, here it is minimum over j Lj minus Tij, and whenever step 5 when j is equals to 1, in that case L1 will become the beginning node, that is L1 equals minimum of LSIJ, and LSIJ means LS12. So, it will be minimum of L2 minus Tij, whatever calculation you are getting. So, this is for the backward pass. So, once I have calculated using forward pass and using the backward pass, you will have the figure something like this. I am just imaginarily I am drawing one figure like this. Say this activity is 1, this is 2, this activity is 3, this is 4, this is 5. So, at first what we are doing? We are calculating E1, E2, E3, what is E4 we are calculating, then we are calculating E4. Once I am getting E5, then again for the backward pass I am calculating L5, L5 is nothing but E5. From here I can calculate L4, from here I can calculate L3, from here L2 and at last L1. So, L1 I am getting. So, using forward pass you are getting the values of E1, E2, E3, E4, E5, using backward pass you are getting L5, L4, L3, L2 and L1. So, now what are the critical activities, how to find out? Let us see what are the critical activities, the mathematical expression for the critical activity. First I am telling mathematically, then I will explain through the figure. Based on the forward pass and the backward pass calculation, an activity I j will be critical if it satisfies the following condition. What is the condition? Number 1, E I equals L I and E j equals L j. That is, for one activity I comma j, you have the activity I comma j over here. So, this is your ith node, or if I say 1 2. For the activity 1 2 what happens? Let us see. For activity 1 2 what happens? If I told E I equals L I, that is E I equals L I means if E 1 value L 1 value same and E 2 value and L 2 value same, this is say 0 and this is 5 if both are same, and that is second point. So, first point is if E 1 L 1 are same and E 2 L 2 are same for the activity 1 2. This was point number 1. Point number 2 is if E j minus E I equals L j minus L I equals T I j, E j minus E I equals L j minus L I equals T I j. Suppose for this activity T I j, this is equals 5 T I j. What is E j minus E I? That is E 2 minus E 1, that is 5 minus 0 5. Then L 2 minus L 1, that is L j minus L I, that is also 5 minus 0 5, that is equals T I j. T I j here is 5. So, if these values are matching, then this path we call it as the critical activity. Then this activity I j or 1 2 we call it as the critical activity. So, I think it is clear. After calculation I will check whether the values of L 1 E 1 same or not, L 2 and E 2 are same or not, and the difference between E 2 minus E 1, that is this one E 2 minus E 1 should be equals to L 2 minus L 1, and this should be equals to T 1 2. This is the second one, and first one is E1 equals L1 and E2 equals L2. If for the activity 1, 2, if these two conditions are satisfied, E1 equals L1, E2 equals L2 and E2 minus E1 equals L2 minus L1 equals T12. In that case, we say that the activity is the critical activity. But suppose instead of 5, suppose this one is, you consider now this part L1 0, E1 0, after calculation I got E3 7, suppose L3 7 and the value of Tij, this is equal 6. Then here if you see Tij equals 6. So, here for the activity 1 3 what happens now, please check for the activity 1 3 your L1 equals E1, this is valid, L3 equals E3, this is valid, and E3 minus E1, this is equals L3 minus L1, this is also valid, equals same, but this is not equals T13 because T13 is 6. So, therefore, this activity 1 3 is not a critical activity because these two conditions are not being satisfied. Therefore, this is not a critical activity. So, I think whenever I will calculate the activity, how to check whether the activity is critical or non-critical, we have to follow these two. For the activity 1 2, L1 should be equals to E1, L2 should be equals to E2 and your E2 minus E1 equals L2 minus L1 equals, it should be the duration of the activity, that is T12, then the activity 1 2 will be known as the critical activity, otherwise it will be known as non-critical activity. So, once I am observing that, pinpointing what are the critical activities, my next thing is what is the critical path. The sequence of critical activities in a network is called a critical path. Sequence of critical activities known as the critical path. It is the longest path in the network from starting event to ending event and determines the minimum time for completion of the project. So, basically what is happening, suppose I am going something like this, this is the L2 and here again it is say 9, it is 9. So, I am telling it as 4 and then it is 3 and 12. So, if you see the critical activities I can assume as 1 2, 2 4 and 4 5 because they are satisfying my conditions, all these values are same over here. So, the critical path will be 1 2 4 and 5, this one. So, the project completion time, minimum project completion time is becoming now this 12, whatever may be the time of E5 and L5. So, this is the activity, I will show through examples after some time. How we denote it? We denote it by this double line, that is to show the critical path, we afterwards we make it something like this. So, the double line tells that this is the critical path and through this path the activities can be further down. So, the last point if you see, we have written to specify critical path on the network, double lines are used to distinguish from non-critical path. So, whenever I have double line, those are critical path, and if I have single line, that means that path is the non-critical path. The next one is the float and the slack times. So, after I have leveling the network diagram and performing the forward and backward pass computations, now I have to determine the float and the slack time. What do you mean by float? Float time is used for the activities, whereas slack time is used for the events. What is slack of an event? Opposite one also known as event float or the same thing. The slack of an event is difference between the latest time Li and its earliest time. That is, I know what is your latest time Li and what is the earliest time Ei. So, Li minus Ei, whatever the difference, that we call as the event slack. So, and event, if we have a 0 slack time, then we call it as the critical event. Whenever, as I was telling you, for critical activity Ei should be equals to Li. So, Ei equals Li means event slack should be equals to 0. So, event slack is Li minus Ei. So, an event with 0 slack time we call it as the critical event. Now, what is the float of an activity? The activity float, basically there are 4 types if you see, as I have written: total float, free float, independent float and the inference float. What is your total float? Total float is the amount of time by which an activity can be delayed without delay in the project completion date. Amount of time by which activity can be delayed without delay in the project completion time. It implies that the free time associated with the activity which can be used before, during or after completion of this activity. Please note this one: amount of time by which an activity can be delayed without delay in the project completion date. That is, project completion time I am not compromising, but I am delaying the activity. Starting of the activity can be delayed, but this will not affect the total project completion time. You will see in the part which we call it as the crash time also. So, that free time for which the activity which can be used before, during or after completion of this activity. Mathematically, if I have to say total float TFij, this equals to the latest finish time minus earliest finish time, or you can say latest start time minus earliest start time. That is, TFij equals LSij minus ESij. Please note that an activity which has a 0 total float, then we call it as the critical activity. So, to find out the critical activity, we can calculate the total float also. So, total float is equals to latest finish time minus earliest finish time, or latest start time minus the earliest start time. So, the next one is your free float. What is the free float? Free float is a portion of the total float within which an activity can be manipulated without affecting the float of the subsequent activities. Please note this one: a portion of the total float within which an activity can be manipulated without affecting the float of the subsequent activities. Subsequent activities will not be affected, and a portion of the total float, that is free float, is a subset or less than equals the total float. Mathematically, if I have to say, then we will say that free float of an activity Fij, which we denote by Fij, that is free float, equals to Ej minus Ei minus Tij, Ef Ej minus Ei minus Tij. And please note that 0 less than equals Ffij less than equals Tfij, that is free float should be less than equals 0 and it must be less than equals the total float. So, what is the use of free float? Free float is basically used to reschedule the activities with minimum disruption of the earlier plan. That is, say suppose I in this figure, without disrupting these earlier plans, if I can change something on this activity, on this node if I can change without changing the earlier plan, that is suddenly something I have to introduce. I will introduce a new thing or new activity somewhere, but I will try to introduce it in such a fashion that it does not affect the earlier plans whatever I have done. So, for this we use the concept of the free float. The next one is the independent float. A portion of the total float, again the independent float is also a portion of the total float within which an activity can be delayed for starting without affecting the floats of the preceding activities. The earlier one was subsequent activities and this one is the preceding activities, that means afterwards. So, the mathematically if I have to say Ifj, which we denote as independent float, we denote as Ifij, this equals Ej minus Li minus Tij. So, Ifij equals Ej minus Li minus Tij. Please note that negative independent float, if there is any negative independent float, that we will assume as 0, we will ignore it. So, basically the independent float is just the opposite one, opposite in the sense that in the free float we were using the preceding activities, whereas in the independent float we are using the successive activities. The last one is the inference float. In the inference float, a portion of the total float which causes reduction in the float of the successor activities. That is INF ij, this equals to TF ij minus FF ij. Please note the relation that independent float is less than equals free float and is less than equals the total float. Now, let us see some example how we can calculate the critical path. Let us see this example. We want to draw the network for the following project, and also we want to compute the latest and earliest time for each of the nodes and also find the critical path of this one. So, if you see the activity 1, 2, activities are there, immediate predecessor is there, and what is the time it is given. If you see 1, 2 and 1, 3, there is no immediate predecessor and their time is 5, 4. So, if you calculate, you have the activity 1, what we have told, activity 1 and activity 2 has no immediate predecessor. That is, from activity 1 basically is the starting point, and you are starting this. What is the time for activity 1, 2? Time for activity 1, 2 is, if you see, 5, and similarly time for activity 1, 3 is 4, and activity 1, 3 also there is no immediate predecessor. So, we are writing activity 1, 2, time is T I j is this. Now, for 3 activity 1, 3 also you draw it and there is no immediate predecessor, the time taken is 4. What is the next one? The next one is, if you see in the table, activity 2, 4. Activity 2, 4, if you see, immediate predecessor is 1, 2 and its time taken is 6. That means, once activity 1, 2 has been completed, then only you can perform the activity 2, 4. So, 4 should come over here. So, that activity 2, 4 is this thing, time taken is 6. The next one is, if I draw it in the little bit different way, if I let me just draw not this one from the beginning, let me draw it. This is the activity 1, this is your activity 2, time taken is 5, this is your activity 3, time taken is 4. We have the activity 4. Now, 2 to 4, the time taken we have given 6. The next one in the table is activity 3 to 4, and immediate predecessor is 1, 3 and it is starting, time taken is 2. So, for 3, 4 immediate predecessor is 1, 3. So, you see in the figure, after 1, 3 activity 3, 4 will be done. So, now I can draw a join this activity 3, 4, the time taken is 4. Then after that activity 4, 5, if you see, activity 4, 5 can be started after completion of both 2, 4 and your 3, 4, both you can start. So, you see in the figure, after completion of activity 2, 4, after completion of activity 3, 4, you can start the activity 5. So, I am drawing the activity 5, the figure is this one, time taken is 1. Then next one is activity 4, 6, that again starts from activity 2, 4 and activity 3, 4, time taken is 7. So, therefore, after finishing activity 2, 4, after finishing activity 3, 4, your activity 6 can start. So, I am writing this one. So, activity 6 is coming over here. Next you see, the activity 5, 7 can start after activity 5. So, I am drawing this activity 7. After completion of 4, 5, I can start it. So, you are drawing it from the table, time taken is 8. The next one in the table is activity 6, 7, which can start after activity 4, 6 and the time taken is 4. So, therefore, after activity 4, 6, I can start the 6, 7. So, this one and the time taken is 4. And the last one is activity 7, 8, which can start after completion of the activity 6, 7 and 5, 7 and the time taken is 3. Completion of activity 5, 7 and 6, 7, then only you can start activity 8. So, I can write down this. the time taken is becoming 3. I am drawing this thing. Afterwards, directly I will draw. For the first problem, we have drawn it. So, this is your network table, network diagram you have done. First, what I have to do now? I have to calculate the forward pass. Using forward pass, I have to calculate what is E1. I am just first writing this, then I will write on the figures. Your E1, initially your E1 is 0. What is your E2? From the formula E2 I can tell. So, your E1 I am writing E1 as 0 over here. I am just simultaneously I am writing. Your E2 will be maximum over E2 means this is your E2. What will be your E2? E2 will be maximum of E1 plus T12. E1 plus T12. E1 is 0 because from this node only one node is going, from here only one node is attaching. So, E1 plus T12, T12 what is the length? Length is 5. So, basically it is 5 only, there is only one element. So, your E2 you are getting as 5. Now, in the sequence is E3, you have to calculate E3. Similarly, E3 will be maximum of E1 plus T13. What is T13? T13 is 4 and E1 is 0. So, 0 plus 4. So, E3 will be equals to 4. So, E3 is 4. Let me calculate now the E4. Let me write down E4. I am writing this, afterwards I will not write for the next problems. Maximum of E2 plus E4, it is coming from node 2, node 3 also. So, one path will be E2 plus T24, the another one will be E3 plus T34, this length E3 plus T34. So, if you calculate maximum of E2 plus T24, that is 6 plus 5, E2 plus T24, that is 11, and this one is E3 plus T34. So, 4 plus 2 6. So, the value becomes 11. I hope the concept is clear now. So, once I am calculating E4, now I have to calculate E5. E5 is coming from only one node, that is E4 plus this length. So, E5 will be equals to 12. Once I am getting E5, you are getting E5 equals 12. Then you have to calculate E6, 4 to 6, it is 7. The duration is 7. You have to calculate E6 now. For E6, your E4 is 11 plus this time length, that is 7. So, it will become 18, E6 is 18. Your E7 is approaching from two nodes, nodes 5 and node 6. So, I have to calculate the maximum of these two, maximum of E5 plus T57 and E6 plus T67. So, here it is 12 plus 8 20, here it is 18 plus 4 22. So, therefore, the maximum is 22 and 20 is 22. Therefore, your E7 you will get as 22. So, E7 is 22 and E8, the last one, that is this one is E8. This E8, this you will get obtained as 22 plus 3, that is equals 25. So, you are getting 25. So, these calculations, your E8 is 25. These calculations you are getting using forward pass, basically you are getting by forward pass. So, once I obtain by forward pass this one, now I have to go through the same fashion backward pass also. Your backward pass, your L8 will be 25, that is E8. So, your L8 is equals to E8, this is equals 25. So, once I have obtained L8 25, now I can calculate L7. What is your L7? L7 will be equals to the L7 will be, what is the earlier one? Earlier one is equals to E7 minus L8 minus this length, that is 25 minus 3. So, it will be 22, L7 this will be 22. So, E7 and L7 is becoming 22 now. Now, once I am getting the L7, then I can calculate L6. Your L6, it is coming from here 22 minus 4. So, it will be 18. So, L6 is 18. What is your L5? L5 you will get from here 22 minus 8, that is 14. So, you are coming from the backward side and the duration you are subtracting. So, your L5 this is equals to 14 and then your L4. What is your L4? L4 you see, L4 is coming from two sides. If you see, L4 is coming from 5, note 5, note 6. So, L4 you can write down L6, minimum of L6 minus T4 6, comma L5 minus T4 5. L6 minus T4 6, that is 11 you will get, and here L5 minus this, that is 13. So, minimum of 11 and 13, that is 11. So, therefore, your L4 this will become 11. So, I think it is clear L4 is 11, because minimum of this 14 minus 1 13 and 18 minus 7 11, minimum of 13 and 11 is this. So, similarly, you can calculate now your L3. Your L3 will be 11 minus 2, this is equals 9. Your L3 is becoming 9. Your L2 is coming over here 11 minus 6, that is L2 will be 5. Your L2 will become 5, and the last one is L1. Your L1 again is coming from both, here it is 0, 5 minus 5 0, here it is 9 minus 4 5. So, minimum of 0 and 5, this is equals 0. So, by this way you have calculated the next one, that is Li, Lj's also. Now, what will be the critical path, critical activities then? E10, L10. So, one activity is 1 2, because it is satisfying both the conditions over here, if you know. So, 1 2 it is satisfying, then it will satisfying this one 2 4, E2 E4, 11 minus 6 it is 5, and after that it is satisfying the activity 4 6 11, E4 L4 same, E6 L6 same, and their difference is also same. Then E7 L7, 6 7 activity, here also E7 L7 same, and from here from 7 you are going to this. So, I can draw the critical path by double line, as I told, from activity 1 2, then from activity 2 4, after that from activity 2 4 to activity 4 6, and activity 4 6 to 6 7, from 6 7 to 7 8. So, therefore, my critical path is, I can say 1 2 4 6 7 and 8. This is my critical path. I think the problem is clear now. 1 2 4 6 and 7 8, and what is the critical duration? The critical duration or the critical time is, path is this, and the time taken will be obviously the maximum value, that is 25. So, I hope it is clear now that how to find out the solution of this thing. How we are drawing first the network, from the network we are calculating the EIs and LJs, then we are finding the critical path. Let us see the next problem. In the next problem I will do it little faster. Let us see this problem. A building construction company has the project has the following schedules, activities and corresponding times are being given 1 2 2 3 like this way, and we want to construct the network diagram, and then the what is the critical path, and here the added thing is we want to compute the total path also. So, for this particular activities I am just drawing first the diagram 1 2, you can match it with the problem 1 2, this is your, let me make it 3, let this one be 4, this is 2, this is 1. I am not explaining now, because this is same as we have explained in the first problem, from 3 to 6 it will come, 3 6 is there. So, from 3 6 time is 8, then we are having 3 7, 3 7 is 3 7, time duration is 5, then we are having 4 6, that is 4 6 is 3, 4 6 is 3, after 4 6 we are having 5 8. So, say 8 I am drawing here, 5 8, 5 8 is 4, and then after 5 8 you are having 6 9. So, from 6 there is a 9, 6 to 9 it will go, 6 9 duration is 5, then you are having 7 8. So, 7 8 is this one, time duration is 4, the last one is 8 to 9 and the time duration is 3. So, we are drawing the network diagram. On the same way, now you can calculate what will be your E 1. Initially E 1 is 0, your E 2 will be, I am just drawing this, afterwards I will write down directly. E 2 will be E 1 plus 2. So, 2 E 3 will be equals to again 2, because E 1 plus this length E 4 will be equals to 1. What will be your E 5? E 5 is E 2 plus 4, that is 6. What will be your E 6? Your E 6 will be here 8 plus 2 10, here 3 plus 1 4. So, 10 is maximum. So, E 6 is this, your E 7 is 5 plus 2 7, your E 8 this is equals to 6 plus 4 10, 7 plus 4 11, maximum is 11, and this one E 9, this is 11 plus 3 14, 10 plus 5 15, maximum is 15. So, this is your E 9, that is the earliest one from forward pass. From backward pass, now simply you can calculate L 9 will be 15, L 8 this is equals 15 minus 3, that is equals this, then your L 7 12 minus 4, that is equals this, your L 6 will be 15 minus 5, that is equals 10, your L 5 now you will get for 12 minus 4, that is equals this, L 4 will be 10 minus 3 7, your L 3 is how much? Your L 3 you are getting here 8 minus 5, that is 3, and here it is 10 minus 8 2. So, minimum is 2. So, you got 2, your L 2 is equals to 8 minus 4, that is equals 4, and your L 1 this is equals 0. So, I got this one. If you see the critical activities are equal at 1 3 then of course 6 and after that 9. So, if I wish I can draw the critical path like this 1 3 6 and 9. So, what is your critical path? 1 3 6 9, and your total cost is cost in terms of time, this is equals 15. Now, we want to calculate what is the TFIJ. Your TFIJ is what? TFIJ, if you remember TFIJ, the formula total float is LJ minus EI minus TIJ, LJ minus EI minus TIJ. So, now you see you are having the activity, just let me draw, you are having the duration, you are having the earliest start time, earliest finishing time, you are having latest start time, latest finishing time, and what is the value of the total float. Your activity is 1 2, from the table if you see the duration is 2, what is the earliest start time, what is the earliest finishing time, you can see earliest start time and finishing time is 0 and 2, and the latest start time, latest finishing time is 0 and 4, L 2 is 4. So, latest. So, from this you can get it, earliest start time is 0, earliest finishing time is 2. So, 0 2, earliest finishing start time is 0, L 2 is 4. So, I have written 4. So, your total float basically this minus this, please this one L j minus E I minus T I j, L j minus E I minus T I j. So, it will be 4 minus 2 minus 0. So, this will be equals to 2. On the same way you can calculate for 1 3. For 1 3 whenever you are writing, then I am just now I am writing this is 0, this is 2, because for 1 3 it is E 1 is 0, E 3 2, similarly L 1 0, L 3 2. So, this is 2. If you calculate again 2 minus 0 minus 2, so it becomes 0. So, total float just like this way you can calculate. The next one is 1 4. For 1 4 I am just doing the last one 1 4, the total duration for 1 4 is 1. The duration is starting 0 1, this is starting 0 7. So, 7 minus 1 6. So, like this way for all others you can calculate of your own. If you see 1 3 is a critical activity, for any critical activity total float must be equals to 0. Please note this thing that for the total float the critical activity must be equals to 0. Now, let us see one more problem. This problem you just see, you can solve it of your own in the same way. Here we have calculated the free float also, you can calculate the free float of your own using the formula whatever we have given earlier. Now, let us come to the next problem, that is one particular case is there. For this particular problem you see the activities 1 2 3, 1 3 2 like this way. Let me draw it. For 1 2 it is 3, for 1 3 it is 2. So, if you see 1 here you are having the activity 2, you are having the activity 3. For 1 2 it is time taken is 3, for 1 3 the time taken is 2. Now, next one is 1 4, 1 4 the activity is time taken is 6. After 1 4 it is 2 4, 2 to 4 that is this one, 2 to 4 it is 3. Next one is from 2 to 5, that is say 5 is here. So, 2 to 5 the time taken is 7. Next one is 3 to 4, that is in this direction, from 3 to 4 it is time taken is this, and the last one is 4 to 5, for 4 to 5 the time taken is 4. Now, from here you can calculate what are the values of E 1. E 1 is 0, your E 2 will be 3 plus 0 3, then E 3 is equals to 2, E 4 this is equals to now E 4 will be this is your 6, this is your 4, this is your 6. So, E 4 is maximum value is 6, and your E 5 is again 6 plus 4, this is 10, 7 plus 3 10. So, E 5 is 10. Next one is L 5, L 5 is 10 you are starting, then your L 4, what is your L 4? L 4 will be 10 minus 4, so it is equal 6. What is your L 3? L 3 you can calculate from here. So, L 3 is your 6 minus 2, so this is 4. What is your L 2? Your L 2 is 10 minus 7 3, this is 6 minus 3, so this is also 3, and E L 1 this is equals 3 minus 3, so it is 0. So, if you see 1 2 4 6, there is a peculiar thing, that is critical path is more than one path I can say it is 1 to 2 and 2 to 5. So, one path you can write as 1 2 and 5, one critical path I am writing the critical path. So, the critical path one is 1 2 and 5. Other one you can say other critical path is 1 2, I can go in this direction 2 to 4 and then from 4 to 6. So, the other critical path is 1 2 4 and 5, this is another critical path. The other critical path is also there, because E 1 L 1 and E 4 L 4 is 0, that is another critical path is 1 4 and 5. So, you see for this particular problem basically we are having 3 critical paths, but for all critical paths the total project duration is same, that is 10. So, therefore, you have to remember one thing, that the project cost or the critical path is not unique. It may not be unique, I will say it may not be unique, there may have more than one critical path, but always the project cost or the duration will be fixed if you have multiple critical paths. So, using the CPM method, basically we have tried to find out what should be the critical path, what should be the critical activities, and what are the values of total float and free float. So, that if I try to readjust certain activities, what will be the effect. Now, if you see, we have taken in the CPM whatever times we have taken, that is deterministic or constant times. In the next class, we will talk about the part which basically deals with the probabilistic time, and also whenever if we can reduce the time, that is if I can crash the time, what will be the effect, that we will see in the next class. Thank you.